Children, whenever a car starts from rest and moves quickly to gain speed, we are pushed back against our seat, right? Also, when a car stops suddenly, we are pushed forward. Also, when a car takes a sharp right turn, we have a tendency to move towards the left side. So these are all the situations where we are accelerating. We have all experienced this when we are riding a bike or whether we are in a car or a bus. And in all these situations, one thing is common. Can you identify that? Yes, speed of the vehicle changes. Or to be more specific, velocity of the vehicle changes in all these situations. When a car starts from rest, its speed increases. When a car stops suddenly, its speed decreases. Also, when a car takes a sharp turn, its velocity or speed changes. Okay, so these are all situations where we are accelerating. Hence, it is clear acceleration means change in velocity. Whenever there is a change in velocity or whenever there is a change in speed of an object, that object is said to be accelerated. And this change in velocity can be increase in velocity or decrease in velocity. See what happens when brakes are applied to a moving car. Yes, its speed decreases and finally it comes to rest. This is a case of acceleration in physics. And generally you may think that this is not acceleration because the speed of the car is decreasing. And you will always try to relate acceleration with increase in speed, right? In your viewpoint, acceleration may be going faster and faster. But it's not like that, my dear children. In physics, acceleration means a change in velocity or a change in speed of the object. This change can be increase in velocity or decrease in velocity. Also, when a car moves faster, its velocity is increasing. That means there is a change in velocity and it is said to be accelerated. So in the first example or in the first case where brakes are applied to a moving car, what happens to the car? Yes, the car finally comes to rest. The speed of the car decreases. So this is an example for acceleration. And to be more specific, it is a negative acceleration. Why? Because the velocity decreases with respect to time. So this is a case of negative acceleration. Negative acceleration is also known as retardation. At the same time, when the car starts from rest and moves quickly to gain the speed, it is said to be moving with a positive acceleration or just acceleration. Children, let me ask you one question. Is there any other way to change the velocity of an object? Yes, my dear children. We can change velocity of an object by changing the direction of that object. Okay. So why is it so? See, what do we mean by velocity? Velocity means speed along with direction, right? So speed plus direction together forms our velocity. If any one, either speed or direction changes, velocity will change. So even if the car is moving with same speed or constant speed, if it changes its direction, okay, if direction changes, we can say the velocity of that car changes. Why? even if speed is same, direction is changing. Okay, so any one, either speed or direction, if any one of these two changes, velocity of the object changes. So even if the object moves with same speed, if it is changing its direction, its velocity will change. So there are three ways to change the velocity of an object. So what are the three ways? Yes, increase the speed, decrease the speed, also change the direction. Okay, so these are the three ways for acceleration. And when you look at the figure, it will be more clear to you. See here, the boy is saying, I am accelerating because I am speeding up. My speed is increasing. Here, I am accelerating because I am slowing down. See, even if the speed decreases, we will say that the boy is accelerating, and to be more specific, it is retardation. Okay, now here the B is saying I am accelerating because I am changing the direction. The speed is same and the object changes its direction. It is said to be accelerated. So these are the three ways for acceleration. Just note down in your notebook. Increase the speed, decrease the speed, change the direction. Children, on the screen you can see some examples. Just try to identify whether there is acceleration or not in each of these cases. Let's start with the first example. A car moving with a constant speed in a straight line. What do you think? Is there any acceleration? In this case, speed is constant, right? And direction is also same. It is moving in the same straight line. So speed is same, direction remains the same. So velocity doesn't change. Hence, there is no any acceleration. Hence, there is no acceleration. Okay. Now consider the second example. Dropping a pebble into water. What happens when a pebble is dropped into water? Yes, the gravitational force acts there. Earth attracts the object towards its center. So Earth attracts this pebble towards it with the gravitational force. Hence its velocity increases. So there is a change in velocity and there will be acceleration. Now, what happens when a ball, when you catch a ball? So when you catch a ball, the ball comes to rest. That means its velocity decreases. So there is an acceleration in that case too. Now what happens when you throw a ball upwards? Yes, when you throw a ball upwards, you are doing it against the force of gravity. So the velocity of the ball decreases. And when it reaches its maximum height, the velocity becomes 0, and from thereafter it comes down. So the velocity of the ball decreases when you throw it. Again, since the velocity changes, there will be acceleration. So hope the concept of acceleration is now clear to you. Next, how do you measure this acceleration? So from the previous examples, it's clear. To measure acceleration, we look at the velocities of the object. We have just observed whether the velocity has increased or whether the velocity has decreased. That means we have just considered the change in velocity of the object with respect to time. So acceleration is nothing but change in velocity with respect to time. And the acceleration is denoted by the symbol A. A is equal to, acceleration A is equal to change in velocity with respect to time. Now, how will you express it mathematically? So, acceleration A is equal to change in velocity means final velocity minus initial velocity, right? and final velocity is always denoted by the symbol v. Initial velocity is denoted by the symbol u. Initial means what? The velocity possessed by the object initially. Final velocity means velocity possessed by the object finally. So change in velocity means final velocity minus initial velocity, that is v minus u divided by time t. So this is the expression to find out acceleration. What will be its unit? So acceleration is change in velocity by time. So in the numerator we have velocity term and in the denominator we have time. What is the unit of velocity? Unit of velocity is meter per second. And what is the unit of time? Unit of time is second. And this second comes to the denominator again. So what you will get? You will get meter by second into second is meter per second square. So the unit of acceleration is meter per second square. Okay, and you may see in your book like this, ms raised to minus 2. This is also right. ms raised to minus 2 means what? Meter second raised to minus 2. Okay, so in both ways we can represent the unit of acceleration. Next, is it a vector quantity or scalar quantity, my dear children? Yes, it's a vector quantity. So it will have a direction, right? So what will be the direction? Its direction is along the direction of velocity, right? So acceleration is a vector quantity. Its unit is meter per second square and it is calculated using this equation. Acceleration A equal to v minus u by t.